I'm Anil Kumar, and in this video we will try to understand whether the given equation is an identity or not. Question is, which of the following are not identities? Justify your answer. So I've got two parts here. The first one is 1 minus 2x squared equals to sine to the power of 4x minus cos to the power of 4x. The second one is sine theta tan theta divided by sine theta plus tan theta equals to sine theta tan theta. You can pause the video, answer the question, and then look into my suggestion. Now, to prove that a given equation is an identity, we should prove that left side is equal to right side for all values of the variable in the domain of the given equation. And to prove that it is not an identity, it is actually sufficient to show that for one particular value in the domain, the equation is not true, because the identity should be true for all values, correct? So we will adopt this philosophy to prove whether the given equation is an identity or not. The first one here, let's begin by right side. It looks like an identity, so we're trying to prove it. Now the right side is sine to the power of 4x minus cos to the power of 4x. We can apply difference of squares and write this as sine square x plus cos square x times sine square x minus cos square x, correct? Now sine square x plus cos square x is 1, right? So therefore we can write this as sine square x minus cos square x. We need to show that it is equals to 1 minus 2 cos square x, only then it is an identity. Now since we want to retain cos, we'll write sine square x as 1 minus cos square x. 1 minus cos square x minus cos square x. And that gives us 1 minus 2 cos square x, which is the left side for us. Now since right side is equal to left side, for all the values of x in its domain, we say that the given equation is an identity, right? So this one is an identity. So therefore, it is an identity. So that is how you have to do it. Now let's look into the second equation. What we notice here is sine theta tan theta divided by sine theta plus tan theta equals to sine theta times tan theta. This is what we are given. This is an equation with equal to sign in between, trigonometric equation. Now it seems that it is not an identity simply because sine theta tan theta equals to sine theta tan theta, left side is equals to right side, only if for all values of all values of theta, sine theta plus tan theta is 1. Only then it becomes an identity, otherwise not. Perfect. Since there is a restriction of that kind, what we will do is we'll just check some values. Let's say if theta equals to let us say 45 degrees, or those of you who are doing in radians, they can take pi by 4, right? So if I take theta as 45 degrees, for example, right, so that means I'm considering this triangle where the sides are, let us say 1, 1 and square root of 2. In that case, if I substitute the value here, what happens? So we'll substitute for theta as pi by 4 or 45 degrees. So what is sine theta? I should write first here. Sine pi by 4, for example, times tan pi by 4 divided by sine pi by 4 plus tan pi by 4, right? Now in this case, sine pi by 4 is actually equals to 1 over square root 2. So we have 1 over square root 2 times tan pi by 4 is 1 divided by 1 over square root 2 plus 1, right? Now clearly the denominator 1 over square root 2 plus 1 is not equal to 1, right? Therefore, this is not equal to sine theta, tan theta, which is the right side. This is the left side for us. Is that okay? The right side will be only the numerator part, which is, let me write here, sine pi by 4 times tan pi by 4, which is 1 over square root 2 times 1, which is equal to 1 over square root 2. Now if you solve this, what do you get? So you have 1 over square root 2 times all this, which is 1 over square root 2 plus 1, and that is equal to, let me write here, so when you multiply it with the first term, you get 1 plus square root 2. Is that okay? Now 1 over square root 2 is not equals to 1 over 1 plus square root 2, right? Therefore, we can say that this is not an identity, right? So this is not an identity. Is that okay? So you have to take any value, calculate left side and right side, and if both are not equal, so what we find is that the left side is not equal to the right side. Therefore, it is not an identity, correct? So that's how you should do such questions. I hope that helps. Thank you.